Hi everyone, thank you for joining. Now we have another interesting integer equation. So given that x and y are positive integers, we want to find the solution to this equation where 2 to the x minus 3 to the y is equal to 1, right? So if you'd like to pause the video and try it yourself first, then we could go over it together. Right, well, the first thing, which is obvious, that x must be strictly greater than y, right? And let's try to, well, since the minimum value, well, x and y are positive integers, since the minimum value of y can be 1, that means the minimum value of x has to be 2, right? If we plug in 2, 1, x is 2, y is 1, you have 2 squared minus 3 to the 1. What's that equal to? 4 minus 3, which is equal to 1. So we've already found a solution. Now this is, of course, it was just an educated guess, right? And are there any other solutions? Okay, to find the other solutions, if there are any, let's rearrange this equation. We have 2 to the x is equal to 3 to the y plus 1, right? Now, if you focus on this term here, because we know that x is equal to 2, we've used, and the next thing we're going to use is x is equal to 3. So in other words, we are interested in 2 cubed, which is 8, right? Now, let's see what is this number on the right-hand side, whether this number is divisible by 8, right? So one way to do that is to use modular arithmetic. Now let y be an even number where k is a positive integer, right? We have 3 to the 2k plus 1, which is equal to 3 squared to the power of k plus 1. That is 9 to the power of k plus 1, which is equal to 1 to the power of k plus 1 in mod 8, right? Okay, so if you're not familiar with mod 8 simply means you have 1, 2, 3, 4, 5, 6, 7, and 8 where you reset the clock, and then you get 1, 2, and so on. So 9 corresponds to 1 there, right, in mod 8. So in other words, the answer we have is 1 to the k is just 1, 1 plus 1 is 2, 2 in mod 8. So what we have shown that if y is an even number, 3 to the power of y plus 1 is not divisible by 8 because you get 2, right? Now the next thing we try is if y is an odd number. Let's say it's 2k plus 1. I could have used 2k minus 1. So let k be element of positive integers. Now, when we're doing that, of course, we're losing y is equal to 1, because if k is not equal to 0, y cannot be 1. However, we have already tested that situation, so we know that y is equal to 1, x is equal to 2 is a solution, right? So, in other words, we have now 3 to the y plus 1, that's equal to 3 to the 2k plus 1, that's equal to 3 times 3 to the 2k plus 1, that's 3 times 3 squared k plus 1, that's equal to 3 times 9 to the power of k plus 1, so which is the same as 3 times 1 plus 1 in mod 8. Okay. So in other words, this number is the same as 4, 3 plus 1 is 4 in mod 8, right? So this shows that for a positive integer, y, the number 3 to the power of y plus 1 is not divisible by 8, right? Now, what does that mean? Well, it means for any number that is greater than or equal to 3 for y, there will be no solution to this equation. Because if it's not divisible by 8, meaning we had 2x is equal to 3 to the y plus 1, if it's not divisible by 8, so 2 cubed does not divide. So that means it cannot divide 16 or 32 because they are all, so we will have 2 to the 4, 2 to the 5, and so on. They are all divisible by 8, right? So checking the case, x is equal to 3, where left-hand side is 8, is sufficient to conclude that the only solution to this given equation is that when x is equal to 2 and y is equal to 1. Okay, well, I hope you found it interesting. I hope you found it challenging. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.